Okay, we need to start. Focus. Boy, has it been busy since I last saw you. We have a different president in the White House. We know who's going to the Super Bowl. Man, a lot of changes. Crazy. Anybody have any questions to start with? I know it's hard to focus, but you know, we only meet twice a week. We have to focus. I hear people over here talking about horses and something about trailers. Trailers and horses never mix usually. It's never a good deal usually, but you know, if you're not a horse person, you don't know that, but watch out. Yeah. Okay, any questions before I go? Of course, I'm recording, and you know, I have to shut that off about every 15 minutes so it doesn't make too big a file, something like that. I got 3 people to volunteer for Wednesday. I don't have any student speakers today because it got kind of late on Sunday before I decided exactly what we're going to do today, but I've got 3 people already signed up for Wednesday. They don't know their topics yet, but it's going to be something very short about toxicants, something very short. So I'm going to start here with our next gas. We did a lot of carbon monoxide, but since it kills 400 plus people, and I'm sure there's animals that have died too of carbon monoxide, but that's never reported, is it? You know, some animal will die in a house and they don't know why, but they'll never investigate it. So that's always underreported. Now today I'm doing silo gas, which is kind of a rare thing to happen to people and animals, but it does. I think it was a couple years ago, somebody, and then you know why we tell these stories, is so then you know what happened in the past, and you might, if you come ever to a similar situation, you go, I know what might happen, right? There's no guarantees. But silo gas is produced, it's basically nitrogen dioxide. I've got the chemical formula and the name in another slide coming up, so you should always know the name and then the chemical formula. Extremely toxic. This one has some color to it. It's got an odor as well. So you might say, oh, then you know to be careful. Well, if you're in where this gas is at, it takes one breath and you're done. So it's too late. Anyway, it fermentation, that's what silage is, right? There's silage, corn silage, there's alfalfa haylage. Anytime you put something, some plant material in some type of silo, you can get the silo gas. So let me go to the next slide, and I guess I should have this thing hooked up where I can do it on this device that I have in my hand. But anyway, so silo gas can form almost immediately after you put silage in a silo, and I've got like 3 types of silos I'll show you, up to 3 weeks. The problem is it's heavier than air, and you should, for all these gases, you should know, is it heavier than air, about the density of air, or lighter than air? That way, in a static situation, you know where it's more likely to be, right? So if there's like some kind of compartment where there's no airflow, silo gas would hang down at the bottom, below your waist. Anyway. So then I'm going to show you these silo bags. I don't know your background. If you don't know what a silo bag looks like, I'll show you that. I'll show you what a bunker looks like. But wherever there's silage, it's going to be making silo gas. And actually then, and it's interesting, sometimes in these cases, sometimes the weather affects how much gas is made. And in this case, when there's a drought, they tend to make more silo gas. Okay, so heavier than air, and of course I won't go through all this, but since it's being recorded, you can always go, I wonder what that slide really said, although I'll try to point it out. Heavier than air, highest concentration on the surface of silage, and I'll show you that. Always got to have ventilation. The problem is this gas may even flow into the barn. You might say, how does gas flow? Well, I'll show you this upright silo. If there's some kind of hole where the gas can escape and fall down to a barn, even if the top of the silage is 40 feet in the air, you could have this gas fall down into a barn, and depending on how air flows, cattle or other livestock could be exposed to it. Again, this is relatively rare. it's easy to find carbon monoxide poisonings. Every week we could find something. This would be once every other year or something like that. The story I remember is a farmer, I think it was in Wisconsin. It was some day, not too many days after they filled a silo. The family was going to go shopping in Minneapolis, whatever, and he was going to work on the farm while they were gone. Something caused him to go up on top of the silo to maybe grease some equipment, whatever it was. He got overcome by the gas, and then when the family, the wife and the kids came home, where's Dad? And they finally found him up in the top of the silo. I mean, he was already dead because it's just one breath. I'll show you. It makes an acid in your lungs when you breathe it in. So, tragic story. Okay, so why is it dangerous? It comes in contact with the moisture of your lungs, and then it changes into nitric acid. So you breathe in this gas, nitrogen dioxide, and then when it combines with water in the lungs, and remember that big surface area? How do you get a good reaction going? You have a lot of surface area, right? So there's a lot of surface area. Boom, you get the nitric acid, and that's going to physically eat away the tissue. Because remember, the lung tissue is only one cell thick, right? The alveoli. So it wouldn't take long to completely destroy the lung tissue. There'd be a lot of hemorrhaging because you're going to be wrecking blood vessels. I mean, it's can't be pretty at all, unfortunately. Here's the chemical formulas. Carbon dioxide, everybody knows that. Nitrogen dioxide might be something you don't see all the time. And so when nitrogen dioxide combines with water, you get nitric acid, HNO3. Okay? Now carbon dioxide itself really isn't going to bother you too much, but it's going to displace air. So the big kicker here is nitrogen dioxide. Okay, symptoms: coughing, burning, shortness of breath, all that vomiting. So you get this after a mild exposure. If it's a severe exposure, death. It's like one big breath, death in just a few minutes. And the problem is you can have symptoms, even if you just get a little bit exposure, you can have symptoms hours later, so you should always have the person go to a physician when you get exposed to this. Okay, prevent exposure. Well, obviously, if there might be nitrogen gas or nitrogen dioxide gas up there, you can make sure you don't go up there the first 3 weeks. You can have one of these breathing apparatuses if you have to be up there. And I'll show you what that looks like here. So, not many, I guess maybe anybody work on farm or production area where they have any of this stuff, where they have livestock, manure pits or anything? I'm not sure how many people actually have these. I mean, obviously fire departments do, but this is how you protect yourself in those cases. So here's an upright silo. For those that don't know it, you just have some very large silage container, and then you blow the silage up on top. It fills in the bottom and it starts working up this way, and that's an upright silo. Great for silage or haylage. Here's a bunker silo. This is where you have an open area that's got sides, and you dump silage, and then trucks or tractors and loaders will pack it down. I mean, look at how much equipment there is there. And after you pack it down, you always seal it, because excluding the oxygen is very important to let it ferment. And some people will say, well, look at how much equipment you have to have. So then there's a silage bag that looks like this, and it's filling with silage. And the previous picture showed us an unloader here filling up the bag. But they all make silo gas. Okay, so very rare, but it's possible. Now I'm moving on to manure gas. Okay, so this is another gas. So we have to talk about this, and this one is right out in front of Smith Hall. This manure gas is in the sewers. Wherever fecal matter is decaying, it's out there. So it's all underneath the campus. And there's all kinds of these cases. So going back to the silo gas, remember that was really a combination of two gases, right? So do you say silo gas or do you say silo gases? It's probably best to say silo gas, and then you can say there's actually two components. For manure gases, there's 4 gases, okay? Yes, Alexa.
So for the silo gas, it was a combination of the carbon dioxide, the nitrogen dioxide, and the nitric acid?
Well, the two gases are carbon dioxide and nitrogen dioxide, and then when you breathe in the silo gas, the water in the lungs makes nitrogen dioxide. One of the byproducts of that is nitric acid. So you wouldn't find nitric acid any place except where the water is touching the lung tissue, the nitrogen dioxide. Okay, so this is 4 gases formed any time where there's fecal matter. Obviously, in the sewers, there's some fecal matter, but it's always getting flushed out, and so it's maybe not as concentrated as you find on these farms where there's tanks of manure that have actually literally millions of gallons of manure. And you might say, why don't they get rid of it? Well, it's actually valuable as a fertilizer, right? I mean, so they pump it out, irrigate it on fields, they sometimes haul it out by trucks or wagons. So it's a valuable resource. So let's talk about that. And of course, not knowing your background, I guess I got this picture. It doesn't matter if the words are blurry, but a lot of times you'll have a holding area for livestock, like let's say pigs, and then there'll be a pit underneath this building, and it fills with water, manure, urine, feed, dust, you name it. And it's all under here, and when you're ready to remove it, you don't remove it every day, you remove it once every 6 months. Tell me, 3 months? Depends on the weather. You can't spread it on frozen ground, then you get runoff. There's a lot of logistics here. But whenever you do move it, you have to agitate it. And then that's when the gas is released. Because there's all kinds of little bubbles of this manure gas. And it's maybe not too bad because there's probably a little crust on top of the manure. But once you stir it up, that's where you get a lot of trouble. So the best thing is not to have any animals in there when you do that. People early on, they would do this agitation and then kill all the pigs in the barn, not knowing how dangerous it was. So that's, and it doesn't have to be under the building. I'll show you a tank. It can be in an open area. It can be above ground, below ground. Here's one that's called a slurry tank. And it's just an open tank, and there's a lot of manure in there. You store it, and then you can spread it when you need it, or can. So here's the gases. Excuse me. So there's 4 gases in this manure gas. Nitrogen sulfide, that's H2S. Methane, CH4. I don't know what the LEL stands for. I mean, it's got to be some kind of little crazy acronym, but methane, the chemical formula is CH4. Then there's ammonia, NH3, and then carbon dioxide again comes up to play. So, and then it gives some of the characteristics over here, and I'm never going to ask you about how many parts per million does something. The point is there's 4 gases, and they all are very much an irritant. And when you go down to some of these places, which I'll show you some examples, you breathe in all 4 of the gases, and the problem is when there's a lot of that gas, there's no oxygen. So it displaces oxygen. Okay, so let me go back here. Let me go to my document cam, give you a couple of stories here. And I know I'm going to shut this off for 1 second. Okay, so this just happened January 16th. So that's a week ago. This happened a week ago. I think it was in Florida, and what happened was this crew put a road in someplace, and I'm just looking with here. They laid some kind of road, but then some area became sinking or started to sink, and so the crew was called out. And of course, what do? You crawl down in a manhole to see why this road that you just put in is sinking. And the construction workers would probably hardly ever go down into a sewer, right? When you pave roads, you don't go below ground. Something happened. Well, anyway, so he goes in the ground manhole, and then he dies. And then what happens is, it's like a cascade effect. If you've got like people standing above this manhole, and somebody gets into trouble, your reflex is to jump in. So a lot of these accidents, there's multiple deaths because they don't know why that's happening. So then the next person goes down, and then the next person goes down. And then in the reading that's on the website, I think there's one example. Was it 5 people, Ethan, we were looking at the other day? It was a man, wife, 2 kids, and then a farm worker, if I remember right. And so what happens is the first person goes down, gets into trouble, yells for help, or falls over, and then the next person, it's a reflex to go down and help, right? You don't know what's happening, and then another one. And so oftentimes there's 2 or 3. I think in this case it was 3. I'll show you the headline I saw after that. But there tends to be a cascade effect. So I'm sure they did. Sewer gas was the last thing in their mind, right? They're paving. They're always working above. So here's the this was like a day before this headline. So 3 men descend to their death, overcome by the poisonous gas, and it was basically sewer gas. This happens all the time, and I think what happens is it's people that don't normally work in the sewers. Okay. So like in some cases, I don't have the stories printed, but they'll be like, some hotel will have plumbing problems, and they'll send their plumber out to the front of the building and go down a manhole. Like, okay, something's wrong with our plumbing. And then that person runs into trouble, and then the next person goes down. It's not good. Okay. So that's the 4 gases for manure gas. Let's go to radon. I mean, it's very interesting, all these gases we're talking about. They have different methods to kill you. Now, carbon monoxide, silo gas, and manure gas were very acute, right? They could be. Radon is just the opposite. It can't kill you today or tomorrow or the next day. This is years coming. So it's very interesting. So when you study these gases, make sure you understand, is it something that happens quickly? Does it, displace oxygen? Like carbon monoxide, it actually ties to hemoglobin. Okay, radon is radioactive. And so the chemical formula is capital R, little n, and that's radon. I don't care about the atomic number or anything. But it's a radioactive gas. And you might say, why do we study it? Will our animals and us ever be exposed to it? Yes. We've all probably been exposed to some radon gas. It's just a matter of how much. Properties. Can't see it, taste it, whatever, right? Most of those, carbon monoxide is the same way. Most of the other gases, you can see it or smell it or whatever. Anybody live in an apartment where they check for radon? Do you have anybody to come in and do that here? I think you guys have?
I think we have radon detectors.
Okay. Now, is it like, what are you saying? Is it like on the wall? Or?
I think it's attached outside of our apartment.
Oh, okay. Okay. Yeah. Okay. And I think I've heard of that kind where they might get the air that flows out of a building. Okay. So here it is: colorless, odorless, tasteless, and what you get is it's actually a breakdown product of uranium. And this is going to be in the soil, in the rock bed. So if you remember, it's because of the breakdown products of uranium you get radon. I'm not sure, not really interested in the in-between chemicals there. Now, it's classified as a human carcinogen, and of course that term means generating cancer. Okay, so and it's the same group as benzene, asbestos, mustard gas, all that kind of stuff. So it's a known carcinogen. And now I'm taking a little side detour, and it's radioactive, but I want to tell you the 3 types of radioactivity. Because if you know what type of radioactivity you're working with, you can kind of know how to prevent your exposure, okay? So there'll be 3. The first one is called alpha particles, and that's actually what radon is. So radon emits alpha particles. And I guess I don't really care about all the characteristics. It's better to remember alpha particles. There's particles, and they're relatively weak. They can't get through skin. Skin on your body it's like an armor plate, isn't it? There's a lot of dead cells on the top, and then many cell layers thick called stratified squamous epithelium. And radon and alpha particles can't get through your skin. Your skin is a shield. So you might say, what's the danger with radon then? It's alpha particles. It's when you inhale it. Okay? And I'll show you some pictures about where it's found. It's found in homes. So if we're in Indiana, the part of Indiana where we live right now is on a map. It's like a known radon area. And so what happens is animals and people breathe in radon. Question in the back.
Isn't radon the gas between the plates of glass?
What's that?
Isn't it the gas between the glass?
No, that's not radon. The question was, is that the gas between the plates of glass for insulation? No, it's not radon. Anybody know what the gas is? It's
Argon.
argon. I think it's argon, yeah. But that's a good question because, no, it's not radon. Argon. Okay, so what happens is you breathe these particles in, and they're radioactive, and they sit on your lung tissue, and your lung tissue is only 1 cell thick, right? And it damages the DNA of the cells. And over years of exposure, you can develop lung cancer from this exposure to radon. And usually it's stated as the second cause of lung cancer after smoking. But you can't see it. You can detect it with the detectors, but you don't know that you've really been exposed to it. Okay, unless you have the detector. So now that's alpha particles. There's beta particles. They're more powerful. Okay? Notice how the alpha particles were slow particles. This says high speed. I found a great graphic that compares the 3 types of radioactivity coming up. So these are beta particles. So we had alpha particles, beta particles, and then now the 3rd type is gamma rays. Okay. And these will go further, but this is all radioactivity. Okay, so then here, just another thing about radon. Whenever you have radioactivity, there's a half-life. That means how long does it take to get rid of half the radioactivity? 3.8 days. So what's the rule of thumb to decide how long until all of it's gone? Let's say I had a little radon in a bottle that's closed, and I know in 3.8 days, half of it's gone. What's the rule of thumb to say it's all gone? Anybody ever do this? 10 half-lives equals gone. That's how you do it with radioactivity. If I have something radioactive and it's 3.8 days as half-life, in 38 days, I can throw it in the trash. Purdue does that with radioactivity. 10 half-lives equals gone. Now, some of the half-lives are 12 years. So how long do you have to store that stuff? 120 years before you throw it in the trash. Yeah.
Now, is that in a sealed container or a not sealed?
Oh, well, in my example, I said sealed container because I wanted to make sure you knew I wasn't getting more radon. Because the problem in houses, it's always being generated through the foundation and stuff. So it's like, you might say, oh, it's short-lived, relatively speaking. Well, sure, the stuff that came in today in 30 days, it's not gonna hurt you, but then there's more. So, yeah. Okay, anyway, let's keep going here. Here's a great graphic. It shows you how to protect yourself from these types of radiation. Okay, if it's an alpha particle, it can't go through paper. But it can sit on paper, sit on your lung tissue, and damage the DNA. The beta, it can go through paper, but it's stopped by your skin again, because your skin is like a shield. But look at gamma rays. Goes through a brick wall. And when we did in our lab, when I had an endocrinology lab, we used radioactive iodine to label hormones, and that was a gamma emitter. When the source bottle came in, we worked behind a lead brick. Think of a brick that was lead. And we had to had the bottle of the radioactive material behind the lead brick to work for it, because it goes through so many things. Okay. Okay, so I love that graphic. Okay, where does radon come in? Almost any place. It can even come in the water. So your shower can generate radon. It's coming in through the shower, cracks, windows, whatever, okay? And it might not say in my graphics, but it's heavier than air. In fact, it's many times heavier than air, which is very interesting. You might say, well, it's going to sit in the basement. Well, somebody might have a bedroom in the basement, but the problem is it's not static, right? There's always a furnace running, air conditioning running, then the radon can be up in the attic. Doesn't matter if it's heavier in there if the fans are running, right? Okay, so it comes from all over. It's down in the ground, and it's decaying. It's going to come up through foundations. It can be, some things can be sealed. Here's a map that shows where radon is. This purple is the highest in soil. There's Indiana, there's Purdue right there. Okay, North Dakota, all of North Dakota. And of course, this is kind of a guideline, but it's all over. Okay, I saw this little graphic someplace, I steal these off the internet. I say, okay, radon is inhaled into your lungs. Yep, it's radioactive, can be deadly, depends how long your exposure is. Causes at least 22,000 lung cancer deaths a year. So that's amazing. And you should monitor your home if you're in some area that's radon. So how do you monitor your home? Here's what it is. So it's particles, but it can't go through paper. So here's the deal. Let's imagine these two index cards I have. Two different students take them home. And here's what you do. You take these detectors home, you can buy them, and then you set them out for so long. And what happens is the particles hit the paper. I'm being kind of like oversimplified. So on one, I'm going to show you what happens when there's very little radon in the home. Because when you do these detectors, you always got to tell how long they stood out. They were out in the area. That's always got to be. Because if you have a house that's got a lot of radon, over time, you'll have more hits on the paper than a low radon home. And then you send it into a company and they read it. Okay? So now I'm going to show you what it looks like. And I mean, I'm oversimplifying, but this is essentially what happens. So let me put it on the dock cam and then get it focused. On a home that's low, you would have relatively few hits, few alpha particles on the paper. Now these were exposed for the same amount of time. In a home with a higher amount of radon in it, you would have more hits. And then the number of hits, then the company says, okay, that equates to so many what's called picocuries. I'll show you, I think, a table of that. But that's basically what it is. It's like you have some exposure. When I ran a endocrinology lab, when we worked with radioactive hormones that have alpha particles, we wore a little badge. You've seen people do that. This little badge is like a little monitor, and it'll tell you how many times you got hit by alpha particles and beta particles. Okay? So there are detectors. You let them sit out for a certain number of days. Sorry, and I'm not showing you what I'm looking on the screen. And you have to write down how many days it was exposed. Okay? Because time is everything. The longer you leave it out, the more hits there will be. So then here is what you can maybe come back with. And you might want to know, this is picocuries. Pica. So there's milli, right? That's -3rd. Micro, that's -6th. Nano, -9th. Pico is -12th. 10 to the -12th. Picocuries per liter of air. Okay? And so they're saying if your house had 2 picocuries, it's like you're smoking 4 cigarettes a day. And then look at this. If you have 80 picocuries, it's like 160 cigarettes a day. Unbeknownst to you. Okay? Totally amazing. Okay. So, you breathe it in, and it wrecks your DNA over time. And this is very chronic. Even if you lived in a house that had high radon, it wouldn't kill you for years. It takes that long to get that much damage. Okay, the last gas, phosphine. This is interesting. This is the first semester I've ever talked about this stuff. There's so many gases out there. This one's colorless, but it's flammable and it's got an odor, and it's heavier than air. And I've got the chemical formula coming up. This is actually generated because it's in insecticides and rodenticides, right? Killing insects, killing rodents. And what they do, and there's a real life story coming up, what you do is you spread this stuff on the ground, the original chemical, and I'll show you, I think that's coming up here, let's see. Yeah, there it is. Ammonium phosphate. Here's what happens. Ammonium phosphate is spread around, and in this one case I'll show you, and I think I've got the article here, or at least I can tell you about it. Some family member wanted to get rid of some mice that were under a trailer house. So they spread it, and they know that when it combines with water, one of the products is this gas. It's a poisonous gas. And so the mice living on the ground are exposed to the gas that's being generated by this chemical reaction. Okay. But unfortunately, I don't think there's anything left on that one that I want to talk about. Okay. I don't think so. Unfortunately, when it combines with too much water, 4 kids were killed. And this was, I don't think I have another article about it. This is just like 2 weeks ago. Anybody remember this headline? It was in Texas. Maybe I'm the only one that reads these newspapers and looks for morbid things. That's maybe what it is. Anyway, a family member uses ammonium sulfide to get rid of mice. They spread it under the trailer house. Normally there's always some moisture in ground, right? And so you're going to generate this gas. But in this case, some family member, another one I think, maybe it's the same person, took a garden hose and sprayed underneath there. And made a lot of water available, and they made a lot of gas. And 4 people died, and another 6 were sick. I mean, that just shows you. So that's phosphine gas, and that's our last toxic gas we're talking about. Anybody have any questions on that? I'm going to stop there and we start talking about toxicants on Wednesday.